In this example, we have a plane flying with a velocity of 52 meters per second east, and you've got a 12 meter per second crosswind blowing the plane south. We're going to find the magnitude and direction of the resultant velocity at which it travels. So let's go ahead and use a quick coordinate plane here for this one. And what we'll do then is we'll draw in the plane. Now, the plane is flying at 52 meters per second east. So that's your magnitude. So let's make that 52 right here. Okay, 52 meters per second. All right, now there's a 12 meter per second crosswind blowing the plane to the south. So that would be here. And we can just make it a little smaller than the 52. So we'll do 12 meters per second there. Now, this is not really the tip to tail method. So instead, actually, of writing that here, I think what I'm going to do is I'm actually going to write that here, where I've got the tip of the last vector. I'll do the tail of the next one. And so I'll write my 12 meters per second here. Now, what the airplane's actually going to do, it's not going to go straight east. It's actually going to move a little to the south as it continues to try to fly to the east. So if you don't know much about this, perhaps you've been in a boat or seen a boat trying to cross a river or a lake where there's a breeze or a cross current or a current that's coming at you from across. And so even though you might be pointed at a certain direction, your boat will actually be affected by that current. The same thing happens with an airplane with air. In this case, it says find the magnitude and direction of the resultant velocity at which it travels. So we got to do a couple things here. We got to find the magnitude of this vector. Let's call it vector r. So to find the magnitude of the resultant vector, vector r, we're going to do the square root of 52 squared plus 12 squared. And we're going to get an approximate here. So that approximate is about 53.4 meters per second. So it's helping the plane speed up a little bit, and also probably pushing it to the south a little as well. To figure out that angle here, we'll call that angle theta. What we're going to do is we're actually going to use the inverse tangent here. Now, be careful with this one because even though we've listed this as 12 meters per second, the y value is down. So that's going to be negative 12. And then we're going to do that over 52. So just give me a second or two here. I'm going to make sure I'm in the right mode. And then I'll type this into the calculator. And we'll see what that calculator gives us. So it gives us about negative 13 degrees. So that wind is going to push that airplane off just about 13 degrees, which is not nothing for sure. You could also represent this as just being 13 degrees. That's fine. So the direction we'll just list as negative 13, but 13 degrees south of east would be okay. And then the magnitude here, which is the actual velocity of the airplane traveling through the air, would be 53.4 meters per second.